Hi, yeah, good to hear from you again. I just show your last update for the public video yesterday, and we keep on going. So, about what's going on here, I will say concerning the videos I previously did. Uh, one time, one time I mentioned infinitesimal time, referring to the time elapsed in the columns, referring to the columns of the Anaheim's brushless controller timetable. So I apologize for that, because after reviewing those videos, I thought that word doesn't fit really well there. Same as the positioning, I repeated about the positioning of the rotor poles respect to the exact coincidence of the brush and the copper strips of the slasher controller I called. So after reviewing them, as I said, I thought the positioning was pretty clear, because the sensors marked the exact position when there was the activation of the positive and negative and so on. So it was pretty clear, and I repeated it, maybe making it not that clear. uh, so after that, as I said, I went to drawing the mm, plans, the the drawings with all the measures. So I I can show you some. I had a other computer program to make those measurements. uh, I'm gonna show you other picture first. This is what is represented there. As in the center you see a big circle that is supposed to be the cylinder of the slasher controller, which has the pattern attached to it, and those things below are the 4 blocks, which contains 3 brushes each related to those 3 slasher patterns circuits. And that's what is try to draw here. As you can see in white line are those blocks of plastic, which those are for to get the blank pieces length, right? So to for ask for the materials. Here you can see many measurements, many colors and many shit, but I just will say these white lines are the final pieces, and others are all measurements about them. They're perfectly tangent to the center of the, not tangent but perpendicular to the center of the circle. And as you can see here, is just a orientation of the degrees from which each brush should be to be all in place to fit the pattern, right? And each one of those those three segment divisions from the circle fit to one pole of the brushless DC big washing machine motor. Each 3 of them represents one pole, so we have to divide the length corresponding to each paw in three, because for each time one paw acts, the other two uh, for each time one acts, we have to take account there is one positive and one negative for each paw, and one set, as I call it, as the Anhan called it, which is all closed. But in this circuit we could take an open gate through it too, as I showed in last videos. So for each paw we have to divide it in three. Uh, According to this, when I was starting to get those measurements, I realized that it wasn't clear. I didn't realize when drawing in Paint, in the Paint program, that it's not exactly the whole the whole perimeter which we have to divide between the balls. We have to take in account the length of the brush itself, because if we only take in account to divide the whole perimeter of the poles, we will realize that um, for each time it will be a coincidence when the brush is still on, let's say, positive, giving positive, and the next pole is already making contact while this is still making contact, right? So we have to leave an empty space here for the brush to totally disconnect the last step to fit the next one with no other connection. Okay, so if you just divide whole the perimeter in the 48 poles it was, right? So you don't leave any space here for the brush to leave the last connection before it connects the next one, right? It won't work properly. So we had to divide it. I realized it was needed to divide and add, as you see here, an extra space, empty space, for the length of the brush you expect to have, so you don't make multiple connections, which was unwanted. Uh, I haven't had really any, how to say, any feedback, any comment. I don't receive any comment, nor either any email from you or whatever. So I don't know if anything I can I can do. I'm expecting to leave an email there too for the public to contact me, but people don't seem to be very interested. This was other picture, this concerning that the brush is a 2 millimeter diameter copper contact only. So this is the type of brush that I think I decided to take for the prototype, first for the first test, because I realized it was too big in dimensions. The other ones, those carbon brushes, it was 5 millimeters times 8 millimeters. Even that was too big. So I had a reference of a real piece of copper brushes making contacts which looked like this. I reproduced it because I just realized I lost it. I don't find it. So I reproduced it myself just to show you how it looked like, but now I don't have it. It was, as you see, 4 contacts of copper, more or less that size, and they were made of a very thin um, copper strip, as I have here, and they were from a vacuum cleaner contact. So you had those 2 wires from the power coming out, and they were brushing a ring of something looking like brass, yellow rings, which was rounded in contact over it. So you could mm, wrap the, so you could turn the wires around, and it didn't make a uh, so you could turn the wires right around, no problem, no, I don't know how, and they weren't messing around, they weren't, how to call that, so the wires didn't mess up by wrapping the thing. Well, so uh, that's why I'm gonna test with those little brushes. I think so. Because of that, those those little brushes, which looked like this, they had yeah, little shape imprinted like a press, or something little rounded on top. I did that with a screwdriver, but they look pretty much the same. Just to give you a view, those contacts were directly plugged to the wall current, so they were 240 volts here coming from through those little brushes. So no problem. I know there's gonna be about the voltage, and I think that shit uh, dragged a lot of amps too, because it was a vacuum cleaner, and those vacuum cleaner, I don't know, they surely have 10 amp to 20 amps, right? So I think that will run no problem with the voltage and the shit applied to it. The strap I measured it, and I remember the one I have was like 2 decimals of a millimeter less than the one of the piece I found, but I expect no problem even with that. So okay, if this was understood, I can say I ordered, let's see, yeah, I ordered some motors, some outrunners. uh, I wanted to test if I could test with little ones before I go with the big one, right? With the brushless, with the DC big one brushless, to do this experiment of controller slasher thing. So I asked for those fucker, and I were waiting for parts like 2 months, waiting for parts. For sure, you know about that. And finally, they came up, and when they came up, I quickly realized it wasn't the same wiring as it's not the same winding as the as here we big guy um, brushless motor has. I'm gonna show you, kinda wanna show you what's the difference of it. here you cannot see it very well, but you can see there is some wrapping at the basement of at the base of the stator. They're crisscrossing each other. This I asked for four of them. This is how I realized how it was winded. It looks great, right? uh, so shameful to me to do this to a motor. Incredibly shameful, you know. But it's the only way I realized to see it, because as I disassembled the stator from it, the rotor from the stator. Even with that, I couldn't realize exactly how the wiring was connected to each other. It was weird. So I started cutting each leg of it. Let's see if it's shown right. Yeah. I started cutting each one of those legs from it, which you see over here. They still wrapped. They used kinda epoxy glue with the winding, so it was incredibly hard to unwind. I tried it to do unwinding, but it was incredibly hard to do. See, the wire was get broken. The wire broke before I could totally unwrap it. But so this is how I realized it, and the picture I got was like this. As you can see, you have the three wires from the connection, right? Those are blue, yellow, and orange. And I draw them the same color here. Sorry by the light. Uh, as you can see, that's the wiring the winding I realized those motor had. Why I'm telling all this shit? Because finally, by the way, this sorry, even with that winding, I realized I could run it with the brushless and controller, as I'm gonna show you. Okay, that I can show it to you now. So it the how to say that, the pattern of 1 2 3 1 2 3 that the brushless and controller gives um, runs the motor, even if the winding wasn't is not the same as the big one, but it is able to run with the same pattern. That's what I'm trying to say. Turn this thing on. Those are the sensors. I glued it around them. As you can see, here's one. There's other one, and here's one in there. Two. Yeah. So I turn this shit until there's no red light and run. By the way, I'm trying to still testing on what are those, all the compensate loop, those blue shit there. Sorry. I don't want to touch that now. It's hot, it could kill me. This one particularly is the current control limit. This screw here. I by now I blowed up two controllers, that famous click you said. So by playing with that, two controllers clicked. So I removed the fuse of it. I replaced it. It burned again. It seems something inside gets melted or something, and it makes short circuit so bad that everything explodes. I've blown up some fuses and shit. It doesn't work. So, well, I still trying to see what each one of those screwings does exactly. Last time I did some discovery. it, it was just by touching one or the other, or this other. This shit should run. It's not running. Uh, okay, so by touching those, I realized to make this rotor, this variac, to run many RPMs, because depending on what you screw behind there, you put this to the limit and it doesn't goes to very high RPMs. You have, if you screw those things back there the correct way. So you don't have full control only with this variac. You have to. I had to know what was behind there, what to do to get the best output from this control. So that was what I last find out. But I reversed the connection here. Those are the hot wires coming from the wall. I crisscrossed them. The one was the blue, was where the brown one is. So that's I changed those from one place to the other. To change them because I was taking less than 1 volt coming from the phases output, and I said no way, right? Less than 1 volt. And after changing that, I think I there were 2 volts or something like that. I can show it to you right now. I don't remember well. Let's check that. Let's make this shit run. Come on, run, fucker. This is running on amps at the moment. It's pulling a lot of amps. If I don't take care with it, it goes easily to 5 amps and goes upper. It just burns. This gets 50 degrees easily, and well, those tests are going. Let's check the voltage here. Checking the voltage there. What the fuck it says? 0.8. No. 90 millivolt, right? Yeah, 90 millivolt it says. Here. Sorry. Here it says. Oh. Oh, damn. I don't know how many amps I'm pulling out right now. Sorry. So I'm gonna switch it off. Well, never mind. So I'm still testing with those. And what else? What I wanted to say. Yeah, so you have seen the motor runs with the same sequence this controller was putting out to the other one in your videos. So it can run with that 1 2 3 1 2 3 1 2 3 1 2 3 sequence. So that's because that's what is the pattern I wanna put to the slasher controller. So if it is okay, it should work the same on this motor, even if the winding is not the same. Okay. Well, one thing is the cylinder, which of plastic, right, which has the copper pattern on it around. I did a little picture of it to help you guys understand if my words are not so clear. This is something like the slasher controller. The motor is supposed to go attached here, okay, to one side, and so the faces wire coming up. Each one of the faces is attached to one of those orange patterns of this cylinder, and the patterns will determine when it is the time to be open or closed. Each one has to be 1/3 of the other turned in degrees, and also with that space for the brush itself between, as I explained at the beginning of this video, so all the contacts will be okay when it's turning. And let's say this is the plastic cylinder, right? We have cut it a strap of copper, as let's say this one, right? And it has this pattern as I showed in my in my past videos. And let's say this is the brush, right? I I expect to flex it, not bend it, pushing to the cylinder, right? So when it turns, it will make contact, but I expect it not to bend it or whatever, and so it's making contact there, right? And from here it should be all those connected, let's say, to the positive, and expect to have, as you can see here, 4 blocks like that one you see there. You have to expect to you have to imagine there are 4 blocks of brushes as you see here below, right? And that's the whole thing. So I think that everything, that's all I wanted to say pretty much. Let me see, I have a little piece of paper here to write all I wanted to say. Yeah, it's just a quote I wrote, not a quote, but a sentence I wrote when I heard you say that around the spark gap, sorry, there's a pressure ring around the spark gap that it wouldn't allow the air around to come in. Well, and after I hear that, I thought that even if there was a pressure ring around that enclosed that area, um, and the air outside couldn't go in, even there inside there is still air. Okay, if you have pressure there, what is making that pressure? You still have air there. So even enclosed air inside that pressure ring could make the airflow and the smashing to the metal of the other part of the spark gap. And concerning to that too, I found one video. It's from a YouTube channel, I don't know what it's called, Tesla Slayer Ionic Propulsion. Okay, and it shows this. I'm not gonna play it full. It's just a Tesla coil, right? It's playing with the high voltage, the guy, and you see the sparkings coming up, and the guy builds a kind of uh, rotary shit, you see, with some wires, and it makes look like planes. So when the high voltage comes out of them, it pushes the air and the thing rotates, right? Let me stop there. I don't know if you see it right. My shitty camera doesn't picks up it really well. As you see, there's the time when it turns on. So the sparks comes out from the back of this plain looking shit, and it pushes the thing around. So this one and other video, even I saw that those sparks pushes the air around. Okay. Uh, those lightning like shit sparks does push the air. That's what I wanted to mention showing this video. So I think it's mm, this is concerning to about the slasher, the spark gap, right? I think truly there's air, uh, there's a flow of air inside there because of those sparks. There's, let me check, there's something else. No. Okay, yes, the voodoo machine. I finally tested out the. I said in the description of my last video. Sorry. First time I was running the voodoo machine, and this is how I mounted it finally. It is very bad. Okay, but I it's very dangerous to run with because this motor is too powerful. I did a different joint. Finally, I drilled some plastic and I attached it here, so you can see this looks awful. Okay, but it runs. Look how it moves. Oh, it dances. Look how it moves, it dances, it rotates. So I ran this, so I was getting those 500 volts surely. Here I put that into those drawers because I was expecting this to blow away. It's pretty dangerous setup this time, so I was holding this motor with wrenches, with bike wrenches from the brakes and the gearing and that shit. And this one broke. So I don't know how the hell this was so powerful. Well, I received on purpose. I put it on this hand, but in this hand, I put the contacts of 500 volts coming out from this shit directly to my finger, and I tasted their 500 volts through it, and it didn't kill me. But finally I tested some. I was making spark gaps with 2 jumper cables of those Chinese, and I I was I saw the hertz coming up, and also I tasted the 500 shock on my finger. I was pretty happy about it, but I don't have many interest to test with this at the moment because of all the shit I showed you before. But I have it pretty close, as you can tell. I like it a lot. It's great to have that. Thanks to you, sir. Uh, and also, I okay. This was everything I had to say about all the things. How the research is going at the moment, and I wanted to make the best of the time elapsed of this video. I wanted to introduce the next video I'm gonna upload. It is about a total different machine. Uh, and it's in Spanish also because of the origin of it. Uh, and but even I think those English tongued people could understand that, or if they don't understand the word, at least watch the first 5 minutes or so if you want, because I think that's the best information I can give you um, until now, to the date. uh, I also could have other machines which I could put up some information about. Uh, it's a total different new machine and other research, but I'm trying to run them at the same time. So it's very difficult because one time I'm on one of them, and then I jump to the other, to all the other whole other thing, other research, and so time consuming, and I don't advance so much. It's going pretty slow. One thing I realized I didn't set is that that cylinder, sorry, back to the research, back to the slasher controller shit. If this cylinder is the same diameter of the rotor of the motor, the pole length, if you have to divide exact the same length of this pole in 3 times, you see the length which results is not very long. So I expect this diameter, this diameter should be longer, should be bigger than the motor diameter, than the rotor's diameter, to get that division for each pole bigger. So the thing is, you will have a bigger cylinder over running, which doesn't fit with what we are accustomed to, what we were used to see, right, about the motors. But I think that will be better. So you will have here a cylinder bigger, so the length corresponding to this pole, for example, will be bigger in this diameter outside, so you have more length to play with the brushes around, right? That I forgot to say. Okay, so now I'm back. I say goodbye, and I invite all of you to watch the video I will upload soon, which is, as I said, total different research, uh, but it's a new machine, many years of research behind, And also to the Cash Foundation, I give my sincere welcome to it, because I tried to expose it to them once a long time ago, and I didn't do it because I hadn't the data available to do so as I would like, or I think it's correct. I think it's the best way to. But there is it. I will try to expose it to them, because some science, some new science too, which is on development. And I think that you have a very attitude for it. So that's all. Uh, Good to hear from you. And if anything there, please comment. Please make me know. Somebody interested in something. I only received some comment about what it was called, Pleiadian UFO scientist, UFO builder, and nothing else. I received 2 comments from them. I answered them, and there's no answer after. So I don't know if somebody tried to comment. I don't receive any comments. So there is that. I'm kinda pasting this to the wall, and people pass. So right. See you next time, guys. I will upload other video very long. It's a whole other. It's a full class, 2 hours class of that other machine, new machine. I expect you'll enjoy it. And until the next time, stay healthy. See ya.